Hello, this is 16.11, video 1 about electrolysis. How long will it take to plate out 1 kilogram of aluminum from aqueous aluminum ions with a current of 1 amp? Alright, so anytime you have electrolysis questions like this, it's really just a conversion. Like, you could think about it like stoichiometry or something. We're just converting until we get our answer. And in this problem, we can think currents are a conversion factor. So the information we're starting with is the mass of aluminum, and the information we're trying to get is an amount of time. How long will it take? So we're trying to get from kilograms of aluminum to time. So let's think about what steps we'll use here. So we have aluminum in kilograms, and this is chemistry. We know electrons and stuff, so we're going to need to get that into moles. So just experience will help you figure this out. But to get from kilograms to moles, first we're going to want to convert to grams of aluminum, and then we can convert to moles of aluminum. Once we have moles of aluminum, we can consider, we're trying to get from aluminum to aluminum 3+, and electrolysis always involves electrons transferring, and what we're going to need to do is figure out how many moles of electrons are actually transferring. So we can use that from moles of aluminum. We can figure out the moles of electrons transferred. And when we know current is actually amount of charge over time. So if we can get from moles of electrons to figure out how much charge that is, and charge is going to be in coulombs, we can figure out the amount of time in seconds, because amps are coulombs per second. So this is our game plan. Let's talk about what the conversion factors are going to be. When you're going between kilograms and grams, I hope you know that 1,000 grams equals 1 kilogram. When you're going between grams and moles, you can use the molar mass. So aluminum's molar mass is 26.98 grams per mole. So that's our conversion factor for grams to moles. For moles of aluminum to moles of electrons, well, let's just think for a second here. So we have aluminum, and we're trying to form that from aqueous aluminum ions. So we have Al3+, and we're making aluminum. So in order for that to happen, our aluminum ions must gain 3 electrons to become atoms. So for every 1 mole of aluminum, we're going to be needing 3 moles of electrons. So that just depends on the reaction. When you're converting between moles of electrons and charge, that's when we can use Faraday's constant. Faraday's constant is the charge of 1 mole of electrons. And so Faraday's constant is 96,485, and that is the coulombs per mole of electrons. In other words, that's how many coulombs are equal to 1 mole of electrons. So, electrons have a certain amount of charge, and Avogadro's number of electrons would have a charge of 96.485 coulombs. All right, and then the coulombs and seconds conversion, that is when we use our current. So 100 amps means 100 coulombs per second, because an amp is a coulomb per second. So that means 100 coulombs equals 1 second. So that, again, that depends on the problem. Like, whatever the current is, that's your conversion factor to get between charge and time. All right, so it's all set up. Truly, the best way to convert in chemistry is to use the factor label method, so definitely do that. Don't try to think about multiplying and dividing, because you'll probably make a mistake. All right, so we have 1 kilogram of aluminum. And we're going to convert that from kilograms to grams using this conversion factor. So 1 kilogram aluminum is equal to 1,000 grams aluminum. All right. Next step is grams of aluminum to moles of aluminum. So I know that 26.98 grams aluminum is equal to 1 mole aluminum. Next step, moles of aluminum to moles of electrons, and I figured out that's 1 mole of aluminum every mole of aluminum needs 3 moles of electrons. All right, next step in the plan is moles of electrons to coulombs, so like the charge. That's when we used Faraday's constant. 1 mole of electrons has a charge of 96,485 coulombs. And then last, to get to an amount of time, we can convert coulombs to seconds because 100 amps means 100 coulombs per second. All right. You can always double check that all your units cancel. So kilograms of aluminum cancels, grams of aluminum cancels, moles of aluminum cancels, moles of electrons cancels, coulombs cancels, and we're left with seconds. And if you carefully multiply and divide all those numbers, we get 1.07 times 10 to the 5th seconds. And that's how long it takes. And it doesn't tell you, what units anything has to be in. It just says how long will it take in the question. So you can leave it in seconds. That's fine. If you're curious about, how long is that? We can always convert seconds to hours or something just to see something like a number we can understand a little better intuitively. So seconds, there's 60 seconds in 1 minute, and there's 60 minutes in 1 hour. So if we do that, we'll get 30 hours. That's a little bit easier to understand. So it would take just over a day to get 1 kilogram of aluminum from aqueous aluminum ions with a current of 100 amps. All right, so electrolysis questions, they're really just conversions. They're just some conversion factors that maybe you haven't seen before. Here's another problem. What mass of cobalt solid can be produced from aqueous cobalt ions in 1 hour with a current of 15? All right, so remember, current is our conversion factor. That's not like our starting value. So think, what information are we starting with, and what are we trying to convert to? So given that amps is a conversion factor, the thing we are starting with is hours. That's our time. And what we're asked for is mass. So our overall question is we're going from hours to grams. That's our mass. So let's make a detailed step-by-step plan for how we can get from hours to grams. All right, so I know hours is where I'm starting. Just thinking about the conversions we're able to do, we know we're going to need that time in seconds because amps, remember, is coulombs per second. So we can get that time into seconds by going hours to minutes to seconds. All right. Once we have seconds, we can use the current to convert time to charge. So we can go seconds to coulombs. And once we have the charge, we can figure out how many moles of electrons were transferred. And once we know moles of electrons transferred, we can figure out how many moles of cobalt. And once we know moles of cobalt, we can find grams of cobalt, which is what we want, right? The mass. Let's figure out what these conversion factors are. So 1 hour is 60 minutes. We know that. 1 minute is 60 seconds. For seconds to coulombs, we'll use that current 15 amps is 15 coulombs per second, or 15 coulombs in 1 second. Coulombs and moles, that's when we use Faraday's constant. So 96,485 coulombs equals 1 mole of electrons. All right, moles of electrons and moles of cobalt, well, that depends on the cobalt. Now, since we're forming cobalt with a charge of 2 we're starting with cobalt with a charge of 2 and we're forming cobalt atoms, every cobalt needs 2 electrons. So for every mole of cobalt, we need 2 moles of electrons. And then to go between moles and grams of cobalt, we'll just use the molar mass or the atomic mass of cobalt, which is 58.93 from the periodic table. So that's just its atomic mass because it's an atomic solid, cobalt. All right, so now we're all set up. Let's go ahead and convert 1 hour to grams cobalt using all of these steps. And of course, we're using our dimensional analysis or factor label method. All right, we've got 1 hour. We're going to convert hours to minutes. So 1 hour is 60 minutes. Then we can convert minutes to seconds. 1 minute is 60 seconds. Then we can convert seconds to coulombs. We'll use the current. 15 coulombs equals 1 second. Then we'll convert coulombs to moles of electrons using Faraday's constant. So 96,485 coulombs is the charge of 1 mole of electrons. And then we can go from moles of electrons to moles of cobalt, and since we're going from a charge of 2 to a charge of 0, that's 2 moles of electrons per mole cobalt, per 1 mole cobalt. And then since we're asked for the mass of cobalt, we'll just go from moles of cobalt to grams of cobalt using that mass from the periodic table. 58.93 grams of cobalt. All right, so we can check our units. Hours cancels, minutes cancel, seconds cancel, coulombs cancels, moles of electrons cancels, moles of cobalt cancels. So we have grams of cobalt. Multiply and divide all those beautiful numbers, and we get 16 grams of cobalt. All right. So it's a lot like the first problem we did, it's just in the opposite order. So, in the first one, we went from mass to time. In this one, we're going from time to mass. But it's all the same conversion factors, just be careful. All right, an unknown metal is electrolyzed. We know the time, we know the current, we know the mass, we know the solution. We have to identify the metal. All right. Anytime you have to identify the metal or any element, like you just know it's a pure element and you're trying to identify it, it's almost always the case that what you need to do is find the molar mass. And once you have the molar mass, you can just look it up on the periodic table. So if we want molar mass, so we can identify the element. Well, if we know the grams that were plated, if we figure out how many moles were plated, we can find the grams per mole, and then that would be the molar mass. So if we find the moles, we can get the molar mass. All right. So we're not going to be able to use the 0.107 grams until the end when we know how many moles we have. Amps is our conversion factor. So the information that we're going to start with is actually the time. And our plan is to go from the seconds to the moles. And then once we have moles, we can find molar mass and we can identify the element. All right, so let's make a plan. We have seconds. And seconds is the unit we want our time in, so we can convert. We can use the current to go from seconds to coulombs, or the charge. If we have the coulombs, we can figure out how many moles of electrons were transferred. If we know the moles of electrons, we can find the moles of metal M. And that's what we're trying to get to, right? Just moles of M. So let's think about what those conversion factors are going to be. Remember an amp, so it's written AMP, but that means A, and that is coulombs per second. So that means 2 coulombs would equal 1 second, or you can convert between 1 second and 2 coulombs for that with the current. Coulombs and moles of electrons, we use Faraday's constant. 96,485 coulombs is the charge of 1 mole electrons. And then the moles of M. So, all right, we know we're getting the atom M, and we know we're starting with M nitrate. And we know that NO3 has a charge of -1, so that 3 right there means it must be M3 plus. As the ion, it must be a metal with a charge of 3. So that means that every metal ion is gaining 3 electrons to turn into a metal atom. All right, so now we have all our conversion factors. We can figure out the moles of M. So we had 74.1 seconds as our starting value. And we could convert seconds to charge using the current, because it was a current of 2 amps, which means 1 second is equal to 2 coulombs. We can convert coulombs to moles of electrons using Faraday's constant, where it's 96,485 coulombs is the charge of 1 mole of electrons. And then we had figured out that that metal had a charge of 3 originally and went to a charge of 0, so that's 3 moles of electrons per mole metal. So seconds cancels, coulombs cancels, moles of electrons cancels, and our answer will be in moles of metal M, which is going to be equal to 5.11 times 10 to the -4th. Right? Now remember, the actual problem is asking us to identify the metal. But our plan was we wanted to find the molar mass and then look it up on the periodic table. So we now know that 5.11 times 10 to the -4th moles were formed. We also know from the problem that the mass of it was 0.107 grams. So the molar mass is grams per mole. So if we know this many grams equals this many moles, we can take the grams divided by the moles to find the molar mass. So 0.107 grams divided by 5.11 times 10 to the -4th moles equals 209 grams per mole. So that's the molar mass of M. So if we want to identify metal M, we can just look at our periodic table and try to figure out, well, which element has an atomic mass that's closest to 209, and it's actually bismuth. So that's what we're going to say is the identity of the metal. And that's just a good thing to know for any AP chemistry problem, that if you're asked to identify an element, you know the grams, you can figure out how many moles that is, take the grams divided by the moles that are equivalent to each other, and that'll give you the molar mass, and you just look it up on the periodic table.